Hi, I'm Geoff Clarkson, and I'm the founder and Chief Technical Officer of UTComp. UTComp is an engineering and inspection company for FRP composite assets. I'm also the creator of the UltraAnalytix non-destructive testing system, which is in use worldwide in a wide range of industrial sectors. UTComp itself is an engineering and inspection company specializing in FRP and other composite materials. We are revolutionizing the way that all industries that use fiber reinforced polymers, or FRP, inspect these tanks, pipes, and other assets for superior reliability, safety, and return on investment. UTComp's inspection technology, UltraAnalytix, is a game changer for FRP composite assets. The UltraAnalytix system has many benefits. It's non-destructive. There's no need to sacrifice assets for inspection, and the structural integrity of the asset is preserved. It's non-intrusive. Inspectors do not require access to the inside of the equipment for most inspections. This minimizes the need for confined space entry. You can inspect the equipment while it's in operation. There's no need for production downtime. You get detailed service life forecasting reports so you can make the best management decisions for your assets based on hard data. UTComp's inspectors and engineers are also certified under ASNT Central Certification Protocols. And after all, and best of all, it's reliable, delivering results based on a validated algorithm that has been thoroughly tested in the lab and in the field for more than a dozen years. Here's how it works. The UltraAnalytix system combines ultrasonic data that's collected in the field along with a comprehensive external assessment, sends that data to UTComp's office, where it's processed and analyzed by UTComp's engineers and analysts. This assessment includes use of a proprietary algorithm that provides accurate, objective evaluation of the asset. We also detect subsurface structural changes in the composite assets well before they become visible. The client then receives a report that summarizes the current condition of the asset and an estimate of the remaining service life. It's simple, efficient, and incredibly quick. Regular inspections of assets over time allow us to create a monitoring curve to determine the rate of change in your asset's structural integrity. In addition to determining the overall status of the equipment, UTComp will also assess the condition of the corrosion barrier and the extent of damage found. This information will provide asset owners with the opportunity to make decisions based on a combination of corrosion barrier condition and the full thickness FRP condition. UltraAnalytix reports include calculated thickness, the condition of the full thickness, damage to the corrosion barrier, explanation of discontinuities that have been found, and a remaining service life calculation. UltraAnalytix has been in use commercially since 2008. It's the only proven non-destructive testing solution. We have extensively validated it, including more than 500 comparisons between UltraAnalytix and destructive tests. Our database has more than 4,000 assets under inspection with millions of data values, and they accumulate over time, continually making the analysis ever more precise and intelligent. Basically, an overview of the verification is presented on this slide, and we will provide you with all of the information you need to do this verification yourselves if you wish. We obtain samples of the material to be tested. We will take UltraAnalytix readings, subject that same sample to a destructive 3-point bend test known as ASTM D790. And we also ensure that we know exactly what the original condition should have been by doing a lamination sequence. This is how the results comparison plays out. What we're showing here is a chart of the destructive results versus the non-destructive results for the verification testing. An ideal situation would be if the the results all fell on this dotted green line, where we would have the same result for destructive as we do for non-destructive. Well, we're not quite perfect, but in fact, these two little red lines, or dotted red lines, show 15% below destructive and 15% above destructive. We use destructive as the base because that is the value that we know is reliable because it's based on actually breaking a sample. What happens is that about 95% of the time, the values fall within that window or gap of 15% above to 15% below. Even more, when I do a comparison, a correlation of the data points and the green line, I get a correlation of 0.94, which is an extremely high correlation, and that relates, for those of you who are involved with statistics, to an R-squared value of 0.88. We've also got comparisons in here of piping as well as larger diameter FRP, like for storage tanks or even flat panels. Lifetime prediction in the asset management world requires non-destructive methods that can verify structural properties, including polymer damage in this case. And for composites, this actually means that we have to measure the polymer damage, the thickness of the material, and the corrosion barrier damage, including the depth of damage. So standards and codes have been developed over a period of time. We've had 70 or more years of experience with FRP. However, recently I went through and did a quick survey and found in the catalog that there's about 211 standards and codes for design or construction of FRP. There's one code that includes some description of visual inspection, and it's actually as a supplement to the code. It's not in the code itself. There are 0 codes for inspection or fitness for service of FRP. Well, standards and codes also provide specifications and criteria for the design of FRP equipment, piping, tanks, and so on. And in fact, all of them start off and focus on this point at 0 years of age, where we've got 100% of the design values that we start with for construction. They don't include any of the damage mechanisms or consideration of any of the damage that leads to these curves. This one on the left showing the change in the elastic modulus of the polymer. This shows the change in elongation at failure of the polymer. And both of these, by the way, tend to multiply together so that it leads to early cracking of polymers after they've been significantly damaged. UltraAnalytix identifies damage that is not yet included in any standards or codes. If you have any questions, please contact me or Joanne Watton. Here's our contact information, and we look forward to talking with you more about this technology and how it can help you. Thank you.